problems. And so we're going to go ahead and look at this first example. It says volumes 1 and 2 of a 2-volume set of math books sit next to each other on a shelf. They sit in their proper order, volume 1 on the left and volume 2 on the right. Each front and back cover is 1/8 inch thick, and the pages portion of each book is 1 inch thick. If a bookworm starts at the first page of volume 1 and burrows all the way through to the last page of volume 2, how far will it travel? Okay. Now the best way to view that is to actually create a visual, and so I'm going to use these 2 books right here. Okay. You've got 2 books. All right, which one's volume 1 going to be?
Pink.
The orange one, because you're going to put it over volume 1, volume 2. Which one's going to be volume 2?
Pink.
The pink. So we need to find where page 1 of volume 1 is. So here's volume 1, right? Page 1 is right here. So really, if it starts at page 1, it's going to actually start right here. Do you see that? It's not going to have to burrow all the way through the book. What's it going to have to burrow through in volume 1? Just the cover here. And how thick is the cover? 1/8 of an inch. So let's go ahead and write that down. So now we know it goes through volume 2, and it goes all the way to the last page of volume 2. So here's volume 2, right? So let's look at that. So if I turn it and open it, where is, okay, here's the first page of volume 2, right? Here's the last page of volume 2. So let's look how I set that down. Here's the last page of volume 2. So where does the bookworm have to burrow through in order to get to the last page? Just the cover again. So how long is that? 1/8 of an inch. So really, all the bookworm does is go through 2/8 of an inch, which we know is 1/4 of an inch. And it's one of those problems, unless you actually sat down and looked at a visual, it would be really hard to solve that problem. Okay? And in fact, what they try and do is they try and confuse you by talking about the book being 1 inch thick and all of that. Okay? So it's one of those things you might need to somehow make a visual. Okay? You might need to work with somebody, and between the 2 of you, figure out how you're going to solve these problems. Let's look at the next example. It says create a Venn diagram to show the relationships among parallelograms, rhombuses, rectangles, and squares. So real quick, a Venn diagram is something you see a lot in science. It's the one with the circles, kind of the circle diagram. What do we know about the relationship of all of these figures? They're all quadrilaterals, right? What is the biggest, what would be the, which of those 4 would have the most shapes in it? Parallelograms, because there's a lot of parallelograms, right? So obviously I know that parallelograms is going to be the biggest. Are all of these 3 remaining ones parallelograms?
Yes.
Yep. So because a square is rectangle, rhombus, so obviously I'm going to make this a little bit bigger. Okay, so there's my parallelograms. Okay, what do I know about the relationship between rectangles, rhombi, and squares? Okay. Which of those 3 would have the least? Squares, right? Okay, what do I know about all squares? They're all rectangles, right? So really, I'm going to make this a little bit bigger. Okay, so they're all rectangles. What else about all squares? They're all parallelograms. What else are they? They're all rhombi. Okay, so I'm going to do this. And we'll go ahead in just a second. I'm going to go ahead and do this something real quick. And then I'm going to go ahead and group those. Okay, so then, is that one going to work or not? Oh, I didn't want to do that. Undo. Okay, anyway, you can kind of see what there. And our squares are supposed to be here underneath, and I've got to somehow move those. Let me see, reorder, send backwards. There we go. Reorder, send backward. Okay, so you've got your squares in here, and I could actually pull out that. There we go. Let's do that. We'll throw the squares right here. Well, there. Okay. So let's see, does this work?
Yes.
Are some rhombi rectangles?
Yes. No. Yeah. No. No.
Rhombi have all four sides the same.
No.
Do some rectangles have all four sides the same?
Yes. But not all rhombi.
What about rectangles? Is a rectangle a rhombi?
No. Yes. No. Sometimes. Sometimes. Sometimes.
So what do I need to do there?
You need to make those two like even have like parts of each.
I need to do what?
You need to make those two have like parts of each other in each other.
Now what was that again? I got the squares here, right?
You have like parts of each other in each other.
How about that?
Yeah.
Would that be correct? Because obviously rectangles. Okay. But could some rectangles be rhombi?
Yes.
So what do I need to
Turn the
do?
rectangle thing sideways.
What do I need to do?
Spin it.
Part of the rectangle circle will be
Okay. So those kind of just overlap a little bit?
yes.
Okay. There you go. All right, so there you go. And I think that would get you for the Venn diagram. Okay, but it's one of those things just kind of takes trial and error. So this is what you need to do on pages 84 and 85. I need you to do 1 through 6, 10 through 15, 21, and 22.